All right, let's dive in. Today, we're tackling something really core to Java, but something that often feels a bit behind the scenes, the reflection API.
Mm-hmm. It's definitely powerful stuff.
Yeah, you've probably heard of it, maybe know it's under the hood in frameworks like Spring or Hibernate, but really getting it, that's different.
Absolutely.
And honestly, understanding reflection well, it's pretty crucial if you're aiming for those senior Java positions, or even if you just want to properly understand how your tools actually, well, work.
Exactly. Reflection is basically the ability of a Java program to look at and interact with its own structure while it's running. Think of it maybe like the program holding up a mirror.
A mirror, I like that. So the program can see its own classes, fields, methods.
Precisely.
Yeah.
While it's executing, it's fundamentally a runtime capability.
Which is totally different from the usual compile time checks we rely on.
Right. And look, most application developers aren't writing reflection code every single day. It's more for the framework builders, the tool creators.
But understanding it, that shows deeper knowledge.
It really does. It signals you grasp the mechanics behind the frameworks, the language itself. Big differentiator.
Okay, challenge accepted then. We're going to take all this technical info on reflection and really shape it into interview-ready knowledge for you listening. So where do we start? How do we peek into this mirror? What are the main parts?
So the main action happens in the java.lang.reflect package. That's your starting point.
Okay. java.lang.reflect.
And the real core building blocks, the things that represent your code elements, are the field class, the method class, and the constructor class.
Field, method, constructor. Okay, FMC. That's memorable.
FMC, exactly. Good memory aid. These are essentially wrapper objects. They hold the metadata about, well, fields, methods, and constructors.
Gotcha. Metadata wrappers.
You also bump into executable class. That's a super class for both method and constructor because, they're both things you can execute.
Makes sense.
And then there's accessible object class. That one's important. It's a superclass for all three of those, FMC.
Accessible object? Does that name hint at something, like getting at private things?
You're jumping ahead, but yes, exactly. Accessible object is where the methods for bypassing Java's access control live. We'll definitely get to that. Oh, and there's parameter class, too, for method parameters.
Okay, so we have these FMC objects representing parts of the code. How do we actually get info from them, like the name of a field or its type?
Yeah, good question. So all three, field, method, constructor, have a getName method. Pretty straightforward.
Okay, getName.
For the type, field class has a getType method. It gives you back a class wildcard object representing the field's type.
A class object for the type.
Okay. And method and constructor have ways to tell you about their parameter types. Method also tells you its return type, naturally.
What about things like public, private, static, the modifiers? Can we see those too?
You bet. There's a getModifiers method on the FMC classes. It returns an int.
An integer? How does that represent modifiers?
It's a bit mask. Each bit in the integer corresponds to a specific modifier, like public or static or final.
Like binary flag.
Exactly. But you don't usually need to fiddle with the bits directly. The modifier class java.lang.reflect.modifier has handy utility methods.
Like what?
Like modifier.isPublic, modifier.isStatic, modifier.isPrivate, and so on. They take the integer from getModifiers and return true or false. There's even modifier.toString to give you a nice string representation, like public static final.
Okay, so the int is like a control panel, and the modifier class helps you read the switches.
That's a perfect analogy. The control panel, yeah. It's a really neat way to check member characteristics dynamically.
All right, so that lets us examine one specific field or method. But how do you find all the members of a class? Is there a difference between getting, say, just the public ones versus everything, including the private ones? This feels like a key interview question area.
Oh, absolutely crucial. And yes, huge difference. The class object itself has pairs of methods for this. You've got getFields, getMethods, getConstructor.
Try to think the det version.
And then you have getDeclaredFields, getDeclaredMethods, getDeclaredConstructors.
GetDeclared. What's the split?
Right. The getMethods, getFields, getMethods, getConstructors. They return only the public members. And importantly, this includes public members inherited from superclasses.
Public and inherited. Got it.
Now, the getDeclaredMethods, getDeclaredFields, and so on, they give you all members, regardless of access modifier, public, private, protected, package private, but only those declared directly within that specific class. They do not include inherited members.
Okay. So get is public plus inheritance. GetDeclared is all access levels, but only this class.
You nailed it. That distinction, get versus getDeclared, is fundamental. Interviewers love to probe on that to see if you understand the scope.
Makes sense. What about method parameter names? Can reflection tell you those?
Sort of, you can get an array of parameter class objects using the getParameters method on executable, so on method or constructor objects.
And parameter tells you the name.
It can. Each parameter object has methods like isNamePresent and getName, but here's a really common pitfall. By default, Java bytecode does not store the actual parameter names. So isNamePresent will return false, and getName will give you something like arg1.
So how do you get the real names?
You need to compile your Java code specifically with the DORA parameters flag added to the javac command. Only then are the real names stored and available via reflection.
Ah, okay, that explains why frameworks doing things like dependency injection often rely on annotations on parameters, right? They can't just assume that the names will be available.
Precisely. They need a reliable mechanism, and annotations provide that, whereas parameter names depend on that compile flag. It's a limitation to be aware of.
Good heads up.
Now, with all these methods, you can see how you could write tools to inspect any class loaded in the JVM. You can loop through getDeclared methods, maybe recursively call cll.getSuperClass to walk up the inheritance chain.
Sounds incredibly powerful.
It is. But quick caution, Java 9 and the module system change things. By default, reflection between modules is more restricted, especially accessing non-public members of standard Java library classes. If you try to reflectively poke at, say, a private field inside java.lang.string, you're likely going to get an inaccessible object exception.
Okay, so the Wild West days are somewhat over for core library internals.
Somewhat, yes. You need explicit permissions now via module declarations.
All right, we can find members, inspect them. How do we actually, use them to interact with object data, like reading or changing a field's value on a specific object?
Okay, now we're getting into manipulation. For fields, you use the get method and set method on the field object you obtained earlier.
Get and set. Makes sense.
You call field.get and pass it the actual object instance whose field you want to read. It returns the value as an object.
Even for primitives like int.
Yeah, get will automatically box primitives. So an int field value comes back as an integer object. But there are also specific primitive getters like getInt method, getDouble method, etc. on the field object, which return the primitive directly.
And setting value, similar pattern. Field.set. You pass the object instance and the new value. Again, it handles boxing and boxing for primitives, or you can use specific setters like setInt method.
Okay, now the big one. Can you really use this to access, say, a private field? That seems like breaking all the rules.
It does, doesn't it? And yes, you absolutely can. Reflection allows you to bypass standard Java access control.
How?
Before you call get or set on a non-public field or method or constructor, you first have to call setAccessible with true on the field object or method constructor.
setAccessible true, like flipping a switch to ignore private.
Kind of like unlocking a door temporarily. Yeah, that's the memory aid. setAccessible unlocks the door.
Surely there are security implications or restrictions. Didn't you just mention module system stuff? Exactly. This is a huge point and a definite interview pitfall area. Calling setAccessible true can fail. If the security manager is active, it might throw a security exception. More commonly now, with the module system, if you try to set accessible true on a non-public member of a class in a different module, especially core JDK modules, and that module hasn't explicitly opened its package for reflection, you'll get hit with that inaccessible object exception.
So trying to modify like the internal char array of a string, probably not going to fly anymore.
Highly unlikely, and for good reason. It would break assumptions that JVM relies on. So you set accessible true with extreme caution. It's mainly intended for frameworks doing deep integration, not for everyday application code.
Is there a safer way to try and unlock it without an immediate explosion if it fails?
Yes, thankfully. There's trySetAccessible method. It does the same thing as setAccessible true, but instead of throwing an exception on failure, it just returns false.
Much gentler. Allows for graceful fallback.
Exactly. You can check the Boolean result. So you can imagine writing a generic object inspection tool. Iterate declared fields to get private ones too. Call trySetAccessible on each. And if it returns true, then call getToPrint the field name and value.
Or that give everyone a raise idea.
Yeah. Scan objects, find a salary field, double or double, trySetAccessible if true, get the value, calculate the raise, and set the new value. All without knowing the specific class, just relying on the field name and type. Powerful, but needs careful handling.
Definitely a double-edged sword. Okay, fields covered. How about actions? How do we call a method using reflection?
For methods, you use the invoke method on the method object.
Invoke. Seems logical.
You call method.invoke. The first argument you pass is the object instance you want to invoke the method on.
This object, essentially.
Right, and then any subsequent arguments are the parameters for the method itself, passed as an object array or using var args.
What if it's a static method? There's no this.
Good point. For static methods, you pass null as the first argument, the object instance.
Okay, null for static. How do you find the right method object to invoke, especially with overloading? You know, same name, different parameter types.
Right, overloading is common. You have two main options. You could get all methods using get methods or get declared methods, which return arrays, then loop through, checking the name and the parameter types yourself.
A bit manual.
Can be. The more direct way is to use get method or get declared method on the class object again. These take the method name as a string, and then crucially, a variable number of class wildcard arguments representing the exact parameter types you're looking for.
Ah, so you specify the signature, like get method with process data, comma, string.class, comma, int.class.
Exactly like that. It finds the unique method matching that name and signature. If none exists, it throws an exception.
Any weird edge cases with getting methods?
There's a funny one with arrays, the clone method. Every array has it, it's public. But if you try array class.get method with clone, it's not found.
Really? Why not?
It's just a special case handled directly by the JVM, not exposed via the standard reflection get method mechanism for array types. A minor gotcha, but interesting.
Definitely a trivia point. Okay, fields, methods. Can we create brand new objects too? Instantiation.
Yes, absolutely. Using the constructor class, it works very similarly to methods.
Find the constructor, then call something.
Precisely. You get the specific constructor object you need using getConstructor or getDeclaredConstructor on the class object. Again, you pass class wildcard arguments to specify the parameter types of the constructor you want, or no arguments for the default constructor.
And once you have the constructor object,
you call its new instance method, passing the arguments required by that constructor. So if you have my class with a constructor taking an int, you'd get it via cll.getConstructor with int.class, then call constructor.newInstance with 42, for example.
New instance on the constructor. Got it. Now, I feel like I've seen older code using Class.newInstance. Is that still a thing?
Ah, good catch. That's a really important point for interviews and a pattern to avoid. Class.newInstance is deprecated.
Deprecated. Why? It seems simpler for a no-arg constructor.
It was simpler, but it had a major flaw related to exception handling. If the no-argument constructor it called threw a checked exception, Class.newInstance would wrap it improperly, often in an undeclared throwable exception or something similar, without declaring it. This completely broke Java's checked exception mechanism. The compiler couldn't warn you that you needed to handle it.
Wow, that's actually pretty bad. It hides potential errors.
Exactly. It violates a core principle. The correct way, even for a no-arg constructor, is to get the constructor object first using cl.getConstructor with empty args, and then call new instance on that.
And why is that better?
Because constructor.newInstance correctly handles exceptions. Any exception thrown by the constructor, checked or unchecked, gets wrapped inside an invocation target exception. You're expected to catch invocation target exception, and then you can examine the cause. It respects the exception system.
Okay, that's a key distinction. No Class.newInstance is bad, no why it's bad, exception handling, and use constructor.newInstance instead.
Precisely. Shows you understand the evolution and the subtleties.
Right. Switching gears slightly, JavaBeans. How does reflection fit in there?
JavaBeans are really a design convention. Class is designed to be reusable components, often with a no-argument constructor, and properties accessed via getter and setter methods following specific naming rules.
Like getX and setX for a property X.
Exactly. Public type getProperty and public void setProperty, type new value. They originated for GUI builders, but are still super relevant for frameworks, serialization, configuration.
Kind of like a standard protocol for interacting with object properties.
Yeah, that's a good way to put it, like a universal remote protocol. And the property name is usually derived by taking the part after get or set and decapitalizing it. So get salary implies a property named salary.
Any quirks in the naming?
Just a couple. If the part after get set starts with two uppercase letters, like get URL, the property name keeps the capitalization, URL.
Ah, like acronyms.
Right. And for Boolean properties, the convention prefers is property over get property, like is enabled.
Okay, standard conventions. How does reflection help work with these?
Java has a specific API for this called the Introspection API in java.beans. The main entry point is introspector.getBeanInfo passing the class.
Introspector.getBeanInfo. What does that give back?
It returns a beanInfo object. From beanInfo, you can call getPropertyDescriptors method.
And that gives you
An array of property descriptor objects, one for each property identified by the introspector following the conventions.
So a property descriptor represents one JavaBean property.
Exactly. And each property descriptor lets you get the property's getName method, its getPropertyType method, and most importantly, the actual method object for its getter, getRedMethod, and setter, getWriteMethod.
Ah, so the introspector uses reflection to find the getter-setter methods based on the naming conventions and bundles them up nicely in property descriptors.
You got it. It's a higher-level abstraction built on top of basic reflection, specifically tailored for the JavaBean pattern. Makes working with them much easier.
Cool. Okay, what about arrays? Anything special about them in reflection?
Yep, arrays are a bit special. First, a class object representing an array type, like stringArray.class, will return true from its isArray method.
Makes sense.
And you can find out what type of element the array holds using getComponentType method. For stringArray.class, getComponentType would return string.class.
Okay, inspection is clear. What about creating or manipulating arrays dynamically?
For that, you use the static utility methods in the java.lang.reflect.array class. It has methods like newInstance to create arrays, get an element at an index, set to set an element, get length, and so on.
So could you use array.newInstance to write a generic copy of method, something like the arrays.copyOfUtility?
Yes, you could, and trying to do so really highlights a key concept about Java arrays. They have reified types.
Reified types, meaning?
Meaning the array object itself knows its exact component type at runtime. An array created as string array knows it's a string array, not just some generic array.
Okay, so why is that important for copyOva?
Because you can't just create a new object array, new object bracket, new length close bracket, and cast it back to the original array type, say person array. Even if you only put person objects in the object array, it's still fundamentally an object array. The types are incompatible for casting.
Like the box label analogy you mentioned, a box labeled object storage can't just be relabeled person storage.
Exactly. The label is fixed when the box array is created. So a naive copy using new object array would fail because the return type is wrong.
So how does the java.lang.reflect array class help?
The array.newInstance method is the key. You give it two arguments: the component type, class object you want the new array to hold, and the desired length.
Ah, so you get the component type from the original array using getComponentType,
Right.
and you pass that specific type to array.newInstance.
Exactly. So array.newInstance creates a new array of the exact same type as the original, like person array or int array. This new array can then be safely cast back.
That makes sense. It preserves the specific array type.
And one more subtle but critical point, often shown in examples: a generic copy of method usually takes object as its input parameter, not object array.
Why object and not object array?
Because primitive arrays like int array or double array are objects, but they are not instances of object array. Remember the memory aid?
All arrays are objects, but not all arrays are object array.
You got it. That handles both object arrays and primitive arrays correctly. Understanding that is vital for robust reflection code involving arrays.
Okay, that clarifies arrays. Last big topic, dynamic proxies. How do they connect to reflection?
Dynamic proxies are fascinating. There are classes that are generated at runtime by the JVM. These generated classes implement a list of interfaces that you specify.
Generate at runtime, why would you need that?
They're incredibly useful when you want to intercept method calls or add behavior around objects, especially when you don't know the concrete implementation class at compile time, only the interfaces it implements. Think aspect-oriented programming, AOP, logging, security checks.
Like your secretary analogy earlier, intercepting calls.
Perfect analogy. The proxy object is the secretary. It stands in front of the real object, if there is one. When someone calls a method on the proxy, which implements the interface,
The call doesn't go to the real object.
not directly. Instead, the call is automatically routed to a special object called an invocation handler.
Invocation handler, what's that?
It's an interface that you implement. It has just one method, object invoke method with object proxy method, object array args.
Okay, invoke again. What do those parameters mean?
Proxy is the proxy object itself, in case you need it. Method is the method object representing the interface method that was actually called on the proxy. And args is an object array containing the arguments passed to that method.
So your invoke method gets all the details of the original call.
Exactly. And inside your invoke implementation, you decide what to do. You could log the call, Check permissions, modify arguments, maybe call the original method on an underlying target object using method.invoke, or even return something completely different. It's total control over the method invocation.
That sounds really flexible. How do you actually create one of these proxy objects?
You use the static proxy class in java.lang.reflect, specifically the proxy.newProxyInstance method.
New proxy instance? What does it need?
It needs three things, remember: where, what, how.
Where, what, how?
Yep. First, the class loader,
Hmm.
where, to define the new proxy class in, usually the class loader of the interfaces. Second, an array of class wildcard objects, representing all the interfaces the proxy should implement. And third, your InvocationHandler instance, or how that will handle the method calls.
Class loader, interfaces, handler. Got it.
That's the recipe. A classic example is tracing. You could wrap something like an integer, which implements comparable, in a proxy. Then, if you pass this proxied integer into arrays.binary search, your invocation handler's invoke method would get called every time binary search invokes the compare_to method on the proxy. You could print out the arguments, see exactly how the search progresses.
And binary search has no idea it's talking to a proxy.
Completely transparent to binary search. That's the beauty of it. Great for debugging, AOP, decorating objects.
Very cool. Now, you mentioned pitfalls earlier. Is there a catch with that invoke method in the invocation handler?
Ah, yes. The big one. Remember the args parameter, the object array holding the method arguments?
Yeah.
If the original method called on the proxy takes no arguments,
Okay.
the args array passed to your invoke method will be null.
No, not an empty array. Like new object bracket, 0 close bracket.
Nope.
Yeah.
Null.
Yeah.
If it feels inconsistent, right, you'd expect an empty array.
Yeah, it definitely seems like an empty array would be more logical.
It's a known quirk of the API. So the crucial takeaway is, inside your invoke method, you must check if args is null before you try to access args.length or loop over it. Otherwise, you'll get a null pointer exception for no argument methods.
Okay, good heads up. Check for null args. Definitely something to remember for an interview.
For sure. It shows attention to detail.
All right, we've covered a ton. Inspection, manipulation, construction, JavaBeans, arrays, proxies. Let's just quickly circle back on security and best practices to wrap up.
Right. So key reminders. SetAccessible true is powerful but risky. Encapsulation breaking, potential security exception, or inaccessible object exception due to the module system. Use it sparingly.
And prefer trySetAccessible?
Yes, try setAccessible for safer attempts. Also, remember exceptions from invoke methods constructors get wrapped in invocation target exception. You need to catch it and look at the costs.
So, bottom line, when should you actually reach for reflection in your day-to-day coding?
Primarily, use it when you're building frameworks or tools that need to work with code unknown at compile time. ORMs, dependency injection, serialization, maybe dynamic plugin systems, testing tools. That's where its flexibility shines.
And when should you probably avoid it?
Avoid it for regular application logic where you know the types at compile time. Direct method calls are way faster, they're type safe, the compiler helps you, and they're much easier for others, and your future self, to read and understand. Reflection adds overhead lookups, security checks.
Performance hit.
Definitely. If you absolutely must use it in a performance-sensitive spot, consider caching the field or method objects after the first lookup so you don't repeat the discovery process every time.
Good tip. Any advice on organizing reflection code if you do use it?
Yeah, try to centralize it. Put the reflection logic into specific utility classes or methods, document why you're using reflection there, and handle errors robustly. Use trySetAccessible, catch invocation target exception, maybe provide sensible defaults or fallbacks if reflection fails. So, summing it all up, reflection, runtime inspection, and invocation. We covered the core classes, FMC, class, inspection, getName, getModifiers, getModifiers, getDeclared, execution, invoke, Constructor.newInstance, utilities, array, modifier, introspector, dynamic behavior, proxy, InvocationHandler, and the crucial security module aspects, setAccessible exceptions.
And hopefully you listening can now confidently explain reflection versus alternatives, handle setAccessible carefully, know the getFields versus getDeclaredFields difference, understand proxy mechanics, JavaBean conventions, and be aware of performance and security.
Exactly. Knowing why Class.newInstance is flawed, or about the null args array quirk, or the module system's impact that elevates the conversation beyond just definitions.
It shows that senior level understanding of not just the what, but the why and when. So, our final thought for you to ponder. Considering this immense power and the pitfalls, where else in the common Java frameworks or libraries that you use every single day do you think reflection might be secretly pulling the strings? And that brings us to the end of this deep dive. Thanks so much for tuning in. We really hope this breakdown makes you feel way more comfortable with Java reflection, whether it's for that next big interview or just leveling up your Java knowledge.
Hope it was helpful.
If you found this valuable, please do us a favor, hit like, subscribe if you haven't already, and definitely drop a comment below. Let us know where you've seen reflection used, maybe in surprising ways, or tell us what other challenging Java interview topics you'd like us to explore next time. We love hearing from you. See you on the next deep dive.